Okay, so this is another question that involve um, a word problem and is a lot of wording, a lot of a long exercise. Okay, not necessarily very difficult, right? So what I will suggest you again to stop it, the video right here, and read the problem, try to solve it on your own. By now, you should be already able to solve these kind of problems because we solved similar ones, similar to this, right? Okay. All right, so let's try to figure out what are the key words for this, right? So the key words is always really simple. You have to look for the mean, you have to look for standard deviation, and you have to look for what you are asked, right? So what the question, right? So, and one more thing, you need to figure out what normal distribution are you at, right? So are you doing a standard normal distribution? Are you doing just a normal distribution, or are you doing a sampling as well, right? So anyway, so if you read here carefully with this problem, so you can see here, so the newborn elephants are having a mean, so the mean weight, you see this is a keyword, all right, mean weight of newborn elephant, so this is your mean, equals to 220 right here, all right. The second keyword is a standard deviation is 50 pounds, so we know the mean is 220, we know standard deviation 50, and the question is right here, what is the probability of newborn weighing at least 384 pounds? All right, so they give you in a word, so you need to transform it into probability inequality in order to figure out, right? And the assumption again, so we are assuming is all the newborn elephant are normally distributed. So this is again an important thing. So we know we're in just normal distribution. All right. Okay. So let's move on to the whiteboard and try to do everything in a chart. I think that's the best way again. So once you have the chart correct, I think the rest is really easy, right? We said we have a normal distribution. So normal distribution is going to be, again, is a bell shape. Now, because you are just in normal distribution, there is no standard word. This axis over here is going to be called the x-axis. All right, just x. And the middle over here, this is going to be the mean, which it is 220. All right. The standard deviation is going to be equals to 50. So these two pieces of information are really important. We need them for the calculation later on. Now, the question is asking you what the probability of a newborn elephant is weighing at least 384. All right. So if I have to write it down as a probability, is it going to be the probability of this x? It can be at least, what this means is greater than 384. I just want to make sure that it's 384. Okay, that's correct, it's 384. So let's figure out. So this is the probability that we are looking for, right? So now, if the mean is 220, so this is the middle. That's where the 220 at. 220 is right there. So what do you think about 384? Where are you going to be? You're going to be obviously on the right side, right hand side. So this is going to be 384. I'm going to call it x1 again. So that's to give the name. So 384 is right there. So if x is greater than 384, it means the x's are going to the right, all the way to the right. So if I'm looking for the probability word, so the probability is indicating that the area limited by the vertical line, the graph, and the horizontal line. So we are looking for this area in here. All right, there you go. So this area is equal to the probability of x greater than 384. And we are looking for what's it going to be? So again, areas means we are using the CDF, right? Normal distribution CDF. So on the calculator, all right? And in order to do that, we need few things. We need the mean. We need the standard deviation is given to us. We need as well the lower bound, all right, and the upper bound, right? So obviously we are here in this part. So do you see this can keep going? So obviously the upper bound is going to be somewhere here, and that's going to be infinity, right? Infinity on your calculator is going to be called 1, and then e, and then 99. And I think we agree on this. So this is going to be the upper bound. Okay. All right. The lower bound, it will be this part over here. Okay. So the lower bound is going to be right, and this is going to be the x1, right? X1 value. Okay, let's make a nice circle. Didn't happen. All right. So moving on to the calculator right now. We're going to plug in everything there. On. Okay, so the way to get into the distributions is going to be second and then vars. So we're going to use the second one. So normal CDF, enter. So if you have any data there, so it's going to be the lower bounds, which is 384. So type it in 384. Then we're going to go to the upper bound. The upper bound we say is plus infinity, so which is 1, and then second, and then comma. You're going to give you the e, and then 99. So that's positive. And then we're going to use the mean. The mean we have 220, so we're going to do 220. And then we're going to put the standard deviation, which is 50, and enter. So we're going to paste it. We're going to figure out, okay, so this is very small number. So what you see here, e to the -4, it means very small number. So this is, I'm going to write what is the calculator there. So it's going to be 5.1909. I'm not going to type everything, and then e to the -4. So what's the meaning of e to the -4? So this is like a scientific notation. It's 5.1909, and this is 10 to the -4. So it's exactly the same thing. This is scientific notation. So if I have 10 to the -4, what this means, that's the decimal point here, you're going to move, you're going to make the number smaller. All right. So making the number smaller, it means you're going to move to the left side, left-hand side. 1, 2, 3, and 4. So the decimal point, you're going to move 4 positions all the way to here. So any empty spots, you're going to be zeros. All right. And then you want to round this to 4 decimals. All right. So you're going to take the first 4, and you have to round this up. So the final answer, this probability, is going to be equals to 0.0005. So this is your answer you are looking for. All right. So let's go back and plug it in and verify it. Okay, so we said the probability is 0.0005. Check it. Very nice. All right, it's done.